Today, we're diving into two really fascinating but also challenging medical mysteries from the world of pediatric neurology. We're going to follow the clues, just like doctors do, to diagnose conditions that can suddenly and tragically change a child's life.
Just think about that for a second. You have a child who's learning, growing, hitting all their milestones. And then, out of nowhere, it's like everything starts moving backward. Skills they just learned start to just vanish. That's the heartbreaking reality at the very center of the two cases we're looking at today.
All right, so our first puzzle. It starts with a toddler whose energy, whose development just seems to be fading away right before his parents' eyes. This is a story about the search for answers when a child's internal power source just starts to fail.
So here's the situation. We've got a 15-month-old boy. He's showing this progressive muscle weakness, what doctors call hypotonia. He's actually losing skills he already learned, which is what developmental regression means. And to make things even more scary, he's having trouble breathing. So as you can imagine, these symptoms kick off a major investigation.
So how do you even begin to figure something like this out? Well, it's a very methodical process. It's like detective work. First, they look directly at the brain with an MRI. Then, they analyze fluids like blood and cerebral spinal fluid for any chemical clues. And finally, they zoom way in, right down to the genetic code itself. Now, to really get what's going on in this case, we have to talk about mitochondria. The easiest way to think of them is as billions of tiny little power plants inside every single one of our cells. Their job is to turn food into the energy that powers everything. I mean, everything, from thinking to moving to just breathing. So you can see if these power plants start to fail, the whole system is in serious trouble. And that's exactly what the lab tests were pointing to. See, when mitochondria aren't working right, the body starts producing way too much lactic acid. And in this boy's case, the lactate levels were way up, both in his blood and his spinal fluid. That is a huge red flag that the cellular power plants were failing. But the real smoking gun, that came from the MRI. It showed this very specific symmetrical damage in two key areas, the basal ganglia and the brainstem. Now, what's so important about that? Well, these are the high-energy demand parts of the brain. They control movement and all our basic life functions. So the parts of the brain that needed the most power were the first ones to go dark. And with all the evidence pointing in one direction, the diagnosis finally became clear: Rett Syndrome. Genetic testing nailed it down, showing a mutation in a specific gene called SIRF1. It's wild to think that this one tiny error in the genetic code was causing such a catastrophic failure in the body's entire energy supply chain. You know, in medicine, a big part of confirming a diagnosis is ruling other things out. So, could the child just get better on their own? No, that just doesn't happen with these kinds of disorders. What about a special diet? Well, that can help manage symptoms for sure, but it can't stop the disease from progressing. The tough reality is that the condition is, by its very nature, progressive. It doesn't stay stable. And this all leads to the absolutely devastating prognosis that comes with Rett syndrome. The source material is very direct about it. The condition is defined by this progressive neurodegeneration, which unfortunately very often leads to an early death. It's just a harsh, heartbreaking reality for families to have to confront. Okay, let's move to our second case. This puzzle is different. It's not about a loss of energy or motor skills, but about losing something just as fundamental: the ability to communicate. So here we have a 5-year-old boy. He was talking, right? Using full sentences, communicating, understanding what people said to him. But now, his words are just disappearing. He's struggling to understand even simple phrases. It's almost as if the language center of his brain is slowly being erased. The investigation here goes down a slightly different road. Just like in the first case, doctors start with an MRI to check the brain's physical structure. But it's the second step that's absolutely key here: an EEG, which is a test that measures the brain's electrical activity. So what the heck is an EEG? Well, the best way to think about it is that it listens to the brain. If a healthy brain's electrical activity is like a beautiful, coordinated symphony, an EEG can pick up on when that symphony turns into just chaotic noise. It's a way to check on how the brain is functioning, not just how it's built. And this is where we find the absolute core of this mystery. The boy's MRI. It came back completely normal. Structurally, his brain looked totally fine. But the EEG, oh, it told a very different story. While he was sleeping, his brain was basically in the middle of a continuous electrical storm. This silent, chaotic seizure activity was disrupting the very circuits responsible for language.
This shocking contrast, a normal structure but chaotic function, led straight to the diagnosis, Landau-Kleffner syndrome. It's a really rare kind of epilepsy where the constant seizure activity specifically targets and messes with the parts of the brain that control language, all without causing the classic convulsions you might think of when you hear the word seizure.
All right, so how do you treat this? It's not as simple as you might think. You can't just throw standard anti-seizure meds at it. Sure, they might quiet some of the electrical activity, but they often don't bring the language back. And therapy by itself can't fix that underlying electrical storm. You have to get to the root of the problem. Turns out, the most effective treatment is actually corticosteroids. Why? Because experts think this syndrome has an autoimmune component. That means the body's own immune system might be mistakenly causing inflammation that's messing up the brain's function. So the goal isn't just to quiet the storm, it's to treat the real cause. So, wow. We've just walked through two very different pediatric puzzles. Let's kind of step back now and see how the diagnostic blueprints compare, and what we can learn from putting them right next to each other. Let's just summarize it, right? Two puzzles, two completely different paths. On one side, Leigh syndrome. The key symptom was loss of motor skills and energy. The primary clues were physical damage on the MRI and high lactate levels. And the cause was genetic, a problem with those mitochondrial power plants. On the other side, Landau-Kleffner. The symptom was loss of language. The primary clue was that wild, abnormal EEG, a functional problem. And the cause was electrical and likely autoimmune. Which leaves us with a really big, thought-provoking question, doesn't it? The first case was basically written into the child's genetic code, a blueprint with a devastating outcome. But the second case offered a chance for recovery if you could find the right treatment. It really makes you think. In the face of these diagnoses, how do we navigate that complex space between what's written in our genes and what we might actually have the power to change?